Hello class, so we've made it to section 1.6, which is almost always everyone's most hated section. It's the word problem section. Um, so I've done something a little different. So first of all, this is one of the few sections where I'm going to recommend you probably read the typed notes also. But I've pre-done a lot of stuff. So there's many equations in this section that they tell you to memorize for different kinds of applications. I'm writing down the two most important ones. So the simple interest equation is this one, okay? And math people are not very creative, all right? If you see a t in a formula, all right, it almost always means time, all right? If it doesn't mean time, then the formula is just wrong because t means time, okay? Um, on top of that, r also almost always means rate, okay? But that's a little more nuanced. Rate could mean many different things, which we'll see later on. And then for this interest equation, well, it's I stands for interest. That's the point of the equation. And P stands for principal, which is basically the starting money, okay? And then second, we have this distance equation where distance equals rate times time. Okay, and this is more like a physics distance, okay? We also have a math, like a geometric distance, which is y2 minus y1 squared plus x2 minus x1 squared. I don't know if this is familiar to you guys, but that's a different kind of distance. That's like measuring distance, where this is like distance traveled, okay? Um, I'm gonna give you a solid piece of information to say there will only be one of these there will only be one word problem on test one, okay? Um, and yeah, you should study a couple of these, okay? So, this is one of the questions we're gonna do. Okay, this one is the interest problem, okay? So, Mary inherits $100,000, okay, and invests it into two CDs, okay. Clearly, Mary is either very old or does not have a proper risk tolerance because CDs pay nothing. All right, but one CD pays 6%. It is also apparently the 1960s because today's CDs pay like 0.1%. And the other pays 0.4 simple interest annually. Okay, if Mary's total interest is 5,025 per year, how much is invested in each? Okay, so we kind of got to dissect this. Okay, so whenever you see a word problem, all right, if there's a number involved, it's probably important. Okay, so just underline these. Okay, two CDs, that's kind of important. Okay, but we see that she inherits this one, this much of money, and invests it. So this is the principal, okay? And these are interest rates, right? Interest rate. So these are R's, okay? And then her total interest, you see the word year here. So time should be year, and total interest is this, I. Okay, so you kind of dissect the words and evaluate what's important. Okay, so the word simple interest is important because this is the simple interest formula, so that means we're going to use that. Okay, so I equals PRT. All right, but we notice that we have two separate rates, right? And she's investing it into two separate accounts. So really, the interest formula we should be dealing with is like this, all right? Where we have two different things being added, all right? So this is account one. You could call this like CD1, and this is account two, and this is like CD2, okay? Now we just kind of gotta fill in the stuff, okay? So if we plug in all of the info, right? I is 2,500. Principal 1, we do not know. That's what we're looking for. Rate 1, I'm just going to call this one the 6% one. So rate 1 is 6%. All right. Very important that you change this to a decimal. Okay. 6% is 0.061, 0.06 is a decimal. Okay. And T time, we're doing this for 1 year, right? How much money? Annually. Okay. So T is 1 year. And then P2, we don't know. The second rate is 0.045, right? 4.5%. And we're also investing this for 1 year. Okay. So simplify some stuff, right? Get rid of these parentheses. And we see that we have this equation. Okay. And so now we have kind of like a problem, okay? And this is the problem with most word problems, is even if you set it up correctly, which is nice, this is also setting it up is the hard part. Now we have to figure out how do we know, like P1, P2, there's two variables, one equation. That's too many to know, right? So if you notice, the only number I haven't used is this one. This $100,000, okay? And that's what we need to use to figure out the rest of the problem, okay? Because, right, if $100,000 is what she's investing into these two accounts, that means P1 plus P2 is $100,000, okay? So, to solve this for P1, okay, so I'm going to subtract P2, okay? So we can now plug this info in. So P1 is P1, all right? But P2 is now, oh, just kidding. All right, I solved for P1, so that means I should plug this in for P1. So $100,000 minus P2, 0.06 plus, and then P2 is P2, okay? And now we are good, all right? We now have one equation and one unknown, okay? So now, you just solve this like a linear equation, okay? So you distribute the 0.06, okay? So this is 6,000 minus 0.06 P2 plus 0.02, 0.045, okay? I'm gonna subtract the 6,000 over, and we're gonna get negative 975, okay? And then I'm going to combine these like terms, all right? And we're going to get negative 0.015 P2, all right? And then we divide it over and we're done, sort of, okay? So P2 equals negative 975 divided by negative 0.015, okay? You punch this into a calculator, and we get the answer of, you don't need the dollar sign, but $65,000. Okay. And so yeah, so that's how much you know invested into P2, and then you can plug this into here, and that'll tell you that P1 is like the rest, right? So P1 is $35,000. Okay, and then you're done, right? And then so let me write down the answer. Okay, so word problems, I know a lot of math professors would like you to write a sentence, all right? So P2 is the one with a 4.5, so this is invested into the CD with 4.5% with a 4.5% interest rate. While $35,000 is invested into the CD with a 4.5% interest rate. So, preferably write a sentence, okay, to finish your word problems. If you're running out of time, just make sure you box these and label them. So like the unit here is dollar, okay? That's the bare minimum that you have to do is tell me dollars or kilometers or cents or pesos, whatever the units of the word problem is, you must tell me at the final answer if you don't at least write a sentence. All right? But this is an interest problem, all right? And basically, as soon as you see the word interest, you should remember that we need this formula, okay? Now, the other kind of problem that you should know, okay, especially for the test, is a distance problem. Okay, so let me move this a little up, okay? And so here's a distance problem. Okay, so a jet makes a round trip flight from New York to LA, and the approximate distance between the two cities is 4,200 kilometers. I'm pretty sure that's off. I do not know the distance from New York to LA, but let's pretend it's this. The speed for the return trip was 100 kilometers per hour faster than the outbound speed. If the whole trip took 13 hours, what was the speed from New York to LA? Or what was the outbound speed? Okay. So again, we see numbers. We should highlight the numbers. Okay. These are the important things. All right, and you see the word distance. So this means we should probably be using the distance formula. Okay. But we see that the word faster is being said here. So there's two speeds, right? The return trip speed and the outbound speed. So we need to do something here, okay? So the distance formula is distance equals rate times time, okay? But we are flying, right? We're doing a one trip, New York to LA, and then LA to New York, right, return. And the whole thing was 13 hours. So there's two distances, right? We go there, and then we go back. So actually what I'm gonna do is I'm gonna solve this formula for t. Okay, so instead of distance equals rate times time, I'm gonna set this thing time equals distance divided by rate. Okay, and our rate is code for speed, right? Kilometers per hour is our rate. Okay, so if we plug in, we know the trip took 13 hours. So that's going to go into the time slot. And then kind of like the last problem. Okay, so let me write this down. Right, we have trip 1, right, and trip 2, right? Outbound, return, okay? So I'm going to call this outbound, and this is the return. Okay, so the distance for both of them is actually just 4,200 kilometers, okay? And the difference is the rates, right? So the return trip is 100 kilometers per hour faster. Okay, so let me just write this down. Okay, so we're here, and now we're stuck, right? Now we have to use this fact. So the outbound speed, right, is R1. The return speed is 100 kilometers faster, so plus R1. Okay, so outbound speed return. Okay, so now we can plug this in to R2 and we get 13,4200 R1 plus 4200 R1 plus 100. Okay. And now we solve this like a rational equation, right? So we solve this like we learned in the previous section. So actually, I'm going to multiply everything, which this is illegal notation, don't copy me. But I'm going to multiply everything by R1 plus 100 to get rid of the fractions, okay, because we do not like fractions. All right, so we get 13 R1 plus 100 equals 4,200 R1 plus 100 plus 4,200 R1. Okay, so if you distribute this and cancel all of the stuff, we should get to this equation. Okay, now I'm gonna FOIL. Okay, so a little painful. Okay, so I'm gonna do this slowly. Okay, because you don't want to mess up. R1 4,200 R1 plus now this is gonna be the number 42,000. Is it gonna be 42,000? No, it's gonna be, I add 2 zeros. What's wrong with me? 420,000 plus 4,200 R1. Okay. Distribute some more. So 13 R1 squared plus 1,300 R1 equals 8,400 R1 plus 420,000. We see that this is a quadratic equation now. Okay, so move everything to the left. Okay. So subtract this from both sides. Minus 429. All right. And we arrive here. Okay, so 13 R1 squared minus 7,100 R1 minus 4,200,000 equals 0. Okay. You can slap this into the quadratic formula or complete the square. Whatever of your choosing. All right, I'm just gonna slap this in the quadratic formula. So R1 equals positive, right? Negative b plus or minus the square root of b squared. Should be negative sign here, but it doesn't matter. Minus 4 times 13 times negative 420,000. All divided by 2a. A is 13, so whatever, so 26 on the bottom. Okay. R1 equals this plus or minus, crunch out whatever here is. All right. If you plug that into a calculator, because you should, you actually get 8,500 magically. Okay. Over 26. And then, right, you have two answers though, right? The plus and the minus. So if you do the plus case, you get 600. If you do the minus case, you get negative 53.8. All right, now here's the important part, right? We're in a word problem, right? And R1 is speed, right? The speed of the outbound trip. So Does this make sense? R1 equals negative 53. No, it doesn't, right? You are not going negative 53 kilometers per hour and, arriving at your destination, right? So the reasonable answer is R1 is 600, okay? So the the question is New York to LA. Yeah. So, yes. So the answer is 600, right? Outbound speed is 600, and then here's important, right? Kilometers per hour. I would dock you if you said miles per hour because that means you clearly aren't reading. But that's the answer. And then just for fun, the return trip, right? The return trip is 100 miles faster. I mean 100 kilometers. I said it now. So the return trip speed is 700 kilometers per hour. Okay. All right, and that's really it for this section. There are different kinds of word problems. I have made the executive decision to kind of leave those for your own pleasure if you want to read them. Really, these are the two that I'm covering, all right? And only one of these should be on your test, all right? So good luck studying this. There's actually, so not only are there notes 6.1, but there's also like a supplemental page with extra word problems if you want to practice them, all right? But that's all for section 1.6, all right? See you next class.